Yeah, please, sir.
Okay, thank you. Thank you, Dr. Jafar, and I'm really happy to be here on the third day, I think, the third day of your proceedings. I've been watching online and offline your various presentations of very good quality. And today I'm going to talk about algal technology, but Phycoremediation and effluent treatment and also restoration of polluted bodies. And the basic principle here is waste to energy. We talk about converting waste into energy always, and we use microalgae in wastewater treatment, and we try to convert microalgae biomass into various forms of energy, the dried biomass or the extraction of the oil, ethanol, all kinds of biogas production. Biomass can be used for producing any kind of energy. So waste energy is our basic idea. And this picture that you're seeing here is actually it's coming up in Colombia. So we have a joint venture company in Colombia called it Phycor, and I think can be on the screen. It's called as Phycor. PHY refers to my, my industry or association called as Phycor Spectrum, and core refers to core biotech of Colombia. So we jointly make this an integrated system of wastewater treatment, production of algal biomass, and conversion of algal biomass into electricity. So this is the basic principle here. With 900 liters of polluted water converted into 7 megawatt clean energy, capturing about 240 tons of carbon per month. And I'll be talking about it later in the time. And this is our team. When we started this wastewater treatment in Colombia some time back, years back. So this is our team, and Phycor is the company that we have registered very recently. And basic idea is to waste to energy. So these four people, including me, and one more fellow, I think he's taking the picture, he's the engineer. So we did a project, and very recently we have a joint venture. We have registered a joint venture called Phycor in Colombia, and this is my partner. He's a medical doctor, MBBS, MD, trauma care, but he's actually completing his PhD in algae in Bogota University in Colombia. I think he'll be submitting his thesis within a month or so. And this is a project that we have started in Colombia. This is the Caribbean Sea, and this is a very small town called Puerto Colombia. And this actually goes to Barranquilla, another coastal town. And this goes to Cartagena, it's another coastal city, which is it's a tourist attraction. So here we have a sewage treatment plant, which is enlarged here to show 1, 2, and 3 tanks. I think the next screen, we'll be seeing all these tanks here, which is not functioning very well. So that has been handed over to us. So we have isolated algae, collected samples from these 3 tanks that you can see. All the 3 samples look different, although they are in the same place. But the algae composition is different. We are now trying to isolate and then produce a consortium which can be used for treatment. So in the meantime, we also complete the process. Then it's okay. So this is the plant that we are going to start in Colombia. So it is the waste to energy, where we are going to treat the wastewater, produce the biomass, and biomass is converted into electricity here. So 900 liters of polluted water, you get 9 megawatt clean energy, capturing more than 240 tons of per month. So about this, I will talk about it later. And this is our team in Colombia when we started the project in one of the petroleum industries in Colombia, where we have put up this facility here. You can see here, and this is the team that we have. And we have very recently registered this Phycor. PHY refers to Phycor Spectrum, Chennai. And core is the core biotech of this man. The company for this man is a medical company. Actually, this man is an MBBS MD, trauma care. So he has now become an algologist. He has submit. I mean, he's going to submit his PhD in algae from Bogota University within a couple of months, within a month. Okay. And the third slide, is it moving? Okay. So you can see here a small city. It's called Puerto Colombia, and this is the Caribbean Sea. And this actually goes to Barranquilla, and this goes to Cartagena. And we see here a very small, that is enlarged sewage treatment plant that has been given to us. And we have started studying the sewage treatment plant, which is not working properly. There are 3 big tanks. And if you see the samples collected from the 3 big tanks, they look different because the algae composition. It looks somewhat reddish and pinkish and dark green and bluish green. We are now analyzing the wastewater samples and making a consortium to be used for wastewater treatment, and that we be installing very shortly. And this is another project we just completed in a slaughterhouse in Barranquilla, Colombia, where we have, I think we see here, PF Plus is our new treatment facility, or what we call as the treatment chamber, which you have patented in Colombia. And this is going to, I think I'll be explaining this a little later. And if you see the enlarged version of this, the larger version, about 200,000 liters capacity of PF Plus that we have put up in the slaughterhouse here in Barranquilla, and we are supposed to clean the water and also produce the biomass. The biomass has higher calorific value. See the next slide, I think you can see. The industrial, the crown core has about 3.5 calorific value kilocalories, and the effluent has about effluent biomass 3.8. That means the effluent grown biomass has a high calorific value than the brown coal that we have analyzed in Colombia. And very recently, I think just before the COVID shutdown, I was in Colombia, and I reached Chennai in the second week of March. When I think within a week we shut down completely for COVID. But during the February and March, I was traveling Colombia. So this is one of the, I think the map will not work. Because the full screen I am not going to. I will go to the next one. And if you see this video, I think this is a video. I don't think this will run. I'll just try. Do you see the? Hello. Do you see the full screen?
Yes, sir. It's visible. Full screen.
You can see the video moving. So this is this video that you are seeing here is from Colombia. I think you can see the area, how it looks. You don't have proper roads to reach the place, and this is the swamp. And we have taken a boat from here to reach the swamp. And this is the collaborators, and this is the team that we have engaged for doing photography and videography. And we have also engaged school students in Colombia. So this place is called San Benito Abad, a very small town, a very small village in near the water body. And these students are selected, and the girls who are having this green T-shirt are the leaders of the groups. And these groups are trained to make posters, and this is the teacher here there, and she takes care of all the students, the volunteers. So the idea is they make posters and then other materials to just to publicize our Phycoremediation technology and what we do there in the villages and the place where they live. So that is very important in Colombia, because whatever you want to do in nature, and the local people should be made available. I mean, made known whatever you're doing. And we also met the village people there with posters drawn by these school students, and this is the team. And they asked a lot of questions. In fact, very interesting questions they asked, and we had to answer all those queries. And this video is going to run. You can see another swamp that we are now looking into. Yes, this is the place where we have put up the facilities. So Phycoremediation is the world's first large-scale phycoremediation protection site in Colombia. So this site is a little far away from the cities and towns and villages. And you can see the race ponds here, and this facility is for growing algae which are collected from the natural water bodies, and we select those species which are going to be useful for remediation, and then grow them in mixture here. A mixture of algae will be grown, and that will be taken to the various spaces. Okay. And this is the facility that you are seeing here. And this is the tanker that we are engaging. You can see the tanker here. So this tanker will be carrying the concentrated algal sample, algal material to this is the aerial view of the facility that we have in our smaller racing ponds and bigger racing ponds. And racing ponds, we grow selected microalgae, and that will be concentrated and taken in containers and put into the water bodies for restoring the water bodies there. So the technology I'll explain a little later. And on March 4th, we also had a press meet because every time we visit Colombia, we used to have a press meet for people from newspaper, TV, the local channels. They come, and I think the meeting will go on for the entire day. They'll be recording and interviewing, asking questions, and presenting whatever we do there. And that is very important in Colombia. Whatever you do, that should be known to people there. And we have also a culture facility in Simon Bolivar University in Barranquilla. The university has given us a facility there, and we have just started growing algae there. And you can see this team, uh, the facility that is not completely full. And I think by now, I think it's already 1 year now. Last March and this March, we are reaching March in a week. I think that will be completely filled with algae, I think, next time I go there. And this is an award we very recently got from the group Latin American Green Awards 2020 Phycoremediation. We are the winners of the Latin Green Award 2020, which is given every year. And it was given on August 22nd when we were sitting inside Corona. And as you can see here, there are about 23 countries in South America, and there are about 2,500 registrants. And we got the award. And this is a video, TV news channel that is actually showing this man, this mayor, governor of Sucre, is visiting our project, and we got the award. And he is now explaining to people in TV. Hector Olimpo Espinosa is the governor. He's explaining what we are doing there. Good. When we got this prize or award, more companies are now coming up with the facility. So this is another restoration we have just started in Colombia. Malanquin swamp in Colombia. I think this number one is the swamp, and this is the Caribbean Sea, and the number two is the Annalena River. So this is situated between the Caribbean Sea and the river, and this is the swamp that we are going to restore. We have started the work already. I think this is very close to the city, Barranquilla, and we have reduction of BOD about 98.3% reduction already we got in this by adding. We also take care of the streams and waterways that do pollute this plant. And this is the cleaning that we are doing. And this has come in the newspaper also, what we are doing there. And we also do a project in Barranquilla with the textile industry called Canon Textile Industry. And you can see here, and I visited 4th March, 4th March, a few days before I returned from Colombia. And you can see here, this is a unique process of microalgae technology employed, and it's a continuous process. First time in the world. Normally we do a semi-continuous process. We don't do continuous process. First time we did this continuous process of reduction of POD, color, and most importantly, toxicity. I think if you can see this photograph down.
I think
that is the different systems. And finally, when it comes to the algal treatment, you can see the water is clear and a very good reduction in BOD, COD, and toxicity. And now we are supposed to scale it.
Sorry, you are in which slide?
So this project started in Iran. And we are growing Dunaliala there, and we are now talking to the industries nearby so that they can give their flue gas going. And we also visited, I think yesterday Dr. Tajin was talking about our Indo-UK project for
Sir,
algal project. He mentioned about the algal bacterial association that is being studied by this group. So this lady, Ala, and this lady, they belong to Swansea University, and this is me, and this is Dr. Tajin. Yesterday, I think I was talking about this. And this is a visit to the water body.
Your presentation is again stuck at some point.
Facility in UK, and we actually gave a presentation, and we are supposed to take it up and then put a sewage treatment plant here. And, it is now not yet started, but this is just to show you that whenever we visited Indo-UK, during Indo-UK project, UK, we always visited a number of industries, and this is one of the industries we visited. And this is another industry we visited with Dr. Tajuddin in Port Talbot in Wales. So this is Tata Steel industry. And
Sir, you are
here, Carol and Ala, they have put up a carbon dioxide flue gas mitigation facility there. So we are supposed to handle the entire wastewater there, and when we were discussing and after I returned from England, I got a phone call, Tata Steel Jamshedpur here, from this gentleman, this man, and he is the leader of the environmental group. And he called me and asked me, we are going to UK to visit Tata Steel, we're going to come to Jamshedpur, we have So from 1994, they have a system for wastewater treatment installed in 1994 from a European company, and there are people there sitting monitoring that. So, but they have problem of color, cyanide, and ammonia. So we have been given the sample by this group, and we did this treatment in the laboratory. So what you see here is treatment. So within 4 hours, you can see the color is completely gone.
So slides.
Let us not worry about the videos. So this is the meeting I had on 4th March, just before I left Colombia, where we met the press people. Whenever I go, the press meet will be conducted at the university. So this is Simon Borrell University, which has given us the space for putting up algal facilities. So this algal facility you see here in Simon Borrell University in Barranquilla, where we have these people who look after this kind of facility. And I think right now they may have more cultures than this. And this is another award that we recently received in I think during August 22nd, 2020. Now we were looking, sitting in the homes for Corona. So we received offline this award, and this award is called as Latin American Green Awards 2020 for a project in Sucre, Pico Sucre, Pico Sucre. So we are the winners. In fact, there are about 25 countries, Latin American countries, and about 2,000 registrants, and about 4,000, more than 4,000 projects submitted, and we got the award. So when we got the award, and a lot of people started visiting us, like the government people, including mayors and the governors. I think last November, one of the governors wanted to meet me, but I could travel to Colombia because of the COVID situation. I think even now the flights are not running. And this is another project that we have done in Colombia for the restoration of the swamp, in Colombia. This is the swamp, and the number 2 is the river, Magdalena River that goes into the Caribbean Sea. So Caribbean Sea, the river, and this swamp. And this is a city, and they want to develop it into a tourist spot. And we have done initial studies and also restoration of this big swamp. You can see here 98.3% reduction in BOD achieved in various spots. We have also treated some of the streams, the polluted streams, which actually go and dump the wastewater in this Malacan fund. So we have started cleaning that also with our technology, and that actually this has come in the newspaper. El Heraldo is a major newspaper, like Times now, like Times of India paper in Colombia. El Heraldo is a big newspaper, and they have put up a news item with maps here and treating the in the waterway that goes into the Malacan Sea. So this is another visit I made in Barranquilla. We are doing a project with the Canon textile industry where we put up our pilot there. And the most important thing about the pilot is this the continuous process. Normally we do a semi-continuous process. That the effluent it's a continuous process for the first and the fourth. And we got excellent reduction in BOD, COD, color, and toxicity. Skip some of the slides. And, yesterday, Dr. Tojin was talking about our Indo-UK project. So whenever we visited, I think 2 times we visited the UK and Plymouth, and then we went to Swansea University and all that. So whenever we go there, we always ask these people to arrange for industrial visit, because I'm interested in more than a lab visiting industry. So this is one of the industries that we visited, Welsh Water. Welsh Water has facilities all over the Welsh area for treating the wastewater generated by the households. They have hundreds of facilities. So this is one of the facilities where we have actually suggested them to put up a pilot here, and we are talking to them, and that will be set up. And we also visited Tata Steel in Wales area. So I think these 2 ladies who belong to the university, Carol and Dr. Alan, I think they have put up a big facility for restoring, for treating the carbon dioxide into flue gas mitigation facility. And we want to put up a facility for treating wastewater there. So whenever I returned from UK, within a month, I got a phone call from the Tata Steel Jamshedpur. He called me and he said, we have a problem with the biological treatment system that actually it was installed in 1972 or 1974, I think. I think they have a problem with the color, cyanide, and ammonia removal. So this is the laboratory treatment we did with the sample obtained from the steel after the initial discussion and final agreement. And you can see within 4 hours, we are able to remove the phenols so that the color is gone and also able to reduce the cyanide ammonia to a very low level. And this is the facility that we have put up, pilot facility, so which is actually smaller version of the big facility that you see here. Then this is the railway track. You see 4 railway tracks here in the action port or facility. And this is the final end of the very long process of wastewater treatment. So the final process, the biological treatment, where they use a combination of bacteria. And we actually added algae along with the bacteria, and that was actually working very well. And we have put up a small pilot plant of 8,000 liters. And the bigger plant you see here that has been reduced to very small system with all the fittings and pumps and facilities. And we have also put up LED lamps, and this project was complete, and we are now waiting for scaling up. And this is another 10-ton also. We have scaled up the plant where we are supposed to handle the electroporation wastewater that has got about 58,000 TDS. It's very high. When the treatment plant goes up to 65,000 TDS, and they bring up color and the TDS, and then we evaporate the water without all the treatment and end up in sludge. We have put up a huge facility, like facility, where we are actually treating the wastewater and also evaporating the wastewater without a sludge formation. So the similar facility has been put up in Pondicherry University in West Bengal. So we have very recently, I think 19 December 2019, we have put up a facility there for 3,000-liter facility for treating the or reject wastewater that is produced by the Tata Steel facility there. And I think I have already taken a lot of time. So I'll take another 20 minutes to talk about other projects like lake restoration and similar projects, so that I can allow for 10 minutes of asking questions. So the presentation was not wanted to do it with full screen mode, and videos are not running. So the lake restoration is a major project that we have started in India and also in Colombia, where we use algae and the power of algae. I don't want to go into detail, but we have also a product called Phycoplus. We call it Phycoplus technology. Phycoplus is the mixture of organically derived nanotech paste, micronutrients, trace elements, growth factors, and enzymes. So this is actually added in very small quantities to enhance the growth of algae, which actually captures light and then does the photosynthesis and takes care of the nutrients and releases oxygen. And oxygen is used by the aerobic bacteria that will act on the organic load and mineralize, and the minerals again taken by the algae. So this actually helps in faster remediation of the polluted lakes, ponds, rivers, and streams. So normally this is happening in any of the body, but by including this Phycoplus, our product, you can enhance the whole process. Instead of taking 1 month, I think it will take just a week. So this is another project we have just started up, where we have problem with cyanobacteria, and when we add our product, that actually in cyanobacteria actually has the capacity using centrophore iron scavenging, and iron is taken by the cyanobacteria. That means the cyanobacteria is scavenging the iron, which is not available for other algae to grow. So one product actually interferes with this iron scavenging centrophore activity, so that the cyanobacteria will no longer become dominant and the other algae start. So normally in a polluted water body, see a cyanobacteria that we advance completely covering the surface that do not allow the light to penetrate. So when the light is not there, water will become black and very high POD and BOD, and a lot of coliform bacteria. So when we treat the lakes, we remove the cyanobacterial duckweed mat, and so that the light penetrates and water appears transparent, and the POD COD decreases and dissolved oxygen increases, and coliform bacteria is completely removed, and the normal food chain is restored. This is what we do. So we have started restoring lakes, ponds, and rivers in India also. This is the first project we did 2 or 3 years back. The lake near Aligarh, a small village near Aligarh. And you can see I think if you see the next picture, you can see the lake before and after. You can see them completely, it is covered with algae and the cyanobacteria and weeds. And you can see within a week or so, you can see the complete removal of the covering, so that water becomes transparent. When the light penetrates, and a lot of beneficial algae start growing, and you can see the parameters after 2 weeks, POD, COD, and TSS becoming more than 84, 80, 98%, and E. coli 99% reduction, coliform 99.5% reduction. So this is the starting point of the restoration of wastewater bodies using algae and our Phycoremediation. And this is another project we did in Chansey. Within 2 weeks, we are able to remove and completely clean the water. And National Mission for Kir Ganga has given us a project in 2008 April, to restore the Gulavati drain. This is they are also approved by Phycoremediation. So if you see the NMCG, Central Pollution Board bulletins, they have mentioned about our technology called Phycoremediation. So that's a critical success. And this is the project we have done in Gulavati. And Gulavati actually goes and joins with a river called Black River or Kali Nadi. Kali Nadi goes for 135 to 45 kilometers, joins Yamuna. So this is one of the projects we undertook 2 or 3 years back. And this is another project we have done in Bulandshahr. And this is a project that we completed in restoration of a polluted water body in, I think, Bihar, and where the fish actually were dying because of the pollution and the absence of oxygen and all that. Now, within 15 days, I think we are able to remove the pollutants and then make the water transparent, and fish stop dying, and dissolved oxygen raised up to 5.5 and pH raised to 7 from 4. And algal bloom was completely clear. And this is another project we did in Sitamarhi, Bihar. And these are now the pictures of the project. And very recently, I can complete with that. Very recently, we have been given by the Meghalaya government a project to restore a polluted river. There are about 2 or 3 or 4. It's 3 rivers, 3 major rivers in Meghalaya, which has become acidic because of the coal mining activity that is going on in Meghalaya. I think suppose you have a land, you can mine the coal, and during coal mining, a lot of sulfuric acid enters into the river in several locations, and you can see the sulfur coated rocks, water becoming transparent because the pH is around 2.5 to 3.5, nothing grows. So this has been actually given to us. So we have put up a huge media facility there with LED lights and all that. So, cleaning up rim by rim, and we have just started November 10th and restoring the river. And you can see we have put up check dams to keep the water for in stagnation in a few places, so that when we remove algae there, it will start correcting the pH. So we have started correcting the pH from 3 to 7, and using the check dam On 12th December, this picture was taken, and you can see the local people before we start restoring. Nobody was coming near the river because it is acidic. Now people have started washing their clothes. We are supplying them with detergents. The idea is the detergent that is going to correct the pH in the waterway further down. So that is the idea. And we have also done another project of the river restoration, most of river restoration. And we have actually signed an agreement with the textile industry, which is actually dumping waste into the river. And we actually correct the restore or treat the textile waste, and then along with algae, the wasted, treated water with a lot of algae is thrown into the river, and you can see what are the result we got. This the upper table is the before starting treatment. The lower one is after starting treatment. Dayan, Mosam, and Chandanpuri. Dayan is the 0 point. Chandanpuri is about 10 kilometers away from the instrument where we are the treatment. And after Chandanpuri, it joins the big river. So we don't need to go beyond that. So it is after 10th kilometer. You can see COD here is 188 before treatment. The same COD, 10th kilometer, becomes 21. So more the water travels, more efficient the treatment will be, because algae also will be carried along with that. So this is, I think, probably 527, like from here. And I think, ask people to, this is the latest facility that I want. It's actually a video. So in DCM Sriram fertilizers in Kota, we have put up a treatment facility, about 18,000 liter facility. You can see 3 tires here, and at night we have put up LED lamps, red, blue, and white lamps for handling COD, BOD sludge. I think with this I can stop. And that's for question. These are some of the companies. Actually, the company list is huge. We are giving very few companies. And actually, my talk actually starts here. It is about 106 slides. I have about 259 slides. Well, go beyond that, we can ask questions. We have another 2 minutes, probably 2 or 3 minutes. You can ask questions, and if there is something which I have to show from other slides, I can go to those slides and show you what we are doing today. Thank you very much.
Thank you, Professor Subramaniam. So even though they have simple disruptions, there have been a lot of patient attentive audience. I could see that the number is increasing with time. And for a nice description of the technology and implementation of this technology. So now the floor is open for questions. Please interact with the expert. Any clarification questions are there? Please come in.
Can I ask a question?
Yes, sir.
Yeah,
please.
please, sir. Please, sir. Go ahead.
Good evening, Dr. Subramaniam.
Good evening,
Very good talk, and congratulations on taking risk in places like Colombia with all their problems, social, security problems.
Yes.
I live a long time in Latin America. Anyway, my question is
Which part of Latin America?
related to drinking water.
Okay.
So we have our city of Rio de Janeiro.
Yes.
Treated algae, it produces jasmine.
Okay.
Jasmine has a strong smell. People don't like that. And some people say it has even health problem like diarrhea. Okay. How do you avoid this production of jasmine by algae? Jasmine is, the compound jasmine, I suppose. If not, I can tell you it's aromatic compounds with 2 benzene rings with OH and CH3. It's a well-known compound produced by algae.
Okay.
Basically, some contamination with sewage water, I think.
Okay. Actually, we don't directly deal with drinking water. So whatever we are doing is only wastewater that we are talking about from industries and also from sewage. And I not heard of this problem in Colombia as such. Probably drinking water, there may be a problem. We don't deal with drinking water. So we deal with the already polluted water in polluted water bodies, respiration in water bodies. And I think I try to search the literature for this, whatever you are saying, and learn myself. And then it's a very interesting question, and it's a learning look into it. Although we don't touch the drinking water, and it is again the drinking water becomes the wastewater later, right?
Can I ask one more question?
Yes, sir. Please.
Yes, sir.
Okay. This is about wastewater treatment only. You talked about BOD, COD going down. In flowing water, how far down do you measure this? Because at the point of treatment, COD, BOD may be low. As it flows and as it reacts, the oxygen gets diminished and it may grow. So, for example, they have Tennessee Valley River Board, the whole river, beyond your district or beyond municipality, it may happen. Not at where the point of treatment. How far down you test the COD and BOD in flowing systems?
Actually, the flowing system I've been showing, they're all drains, small drains, that actually connects big rivers. Big rivers we are not touched so far, because the big rivers are polluted by this small the wastewater streams. So if you clean the wastewater stream, the big river becomes okay. That's the idea of the restoration of Ganges that we are now talking about. In Ganges, you cannot do anything. That is like an ocean. But you can control and then treat all the sewage, nalas, and the other waterways that actually dump in the rivers. And finally, it ends up in Ganges. So that is what I think the project is all about. We have been given a nala in Gulavati in UP, and that goes and joins with a big river called as Kali Nadi. That goes about 135 to 40 kilometers winding, and then that finally ends up in Yamuna. So that is the idea. So we don't want to jump into big rivers, which it's very difficult. And the products and then the treatment system that we are talking about, that works very well with a very shallow, very slow-going polluted streams. That is very easy to manage, not the big rivers.
Thank you for your answer. Basically, unless it is about 80 kilometers from a major river, this may be a problem of time problem also. This is a time problem.
Yes. Anyway, the whatever we are adding, more it travels, I think the efficiency is more. That's what we have found.
This is what I was wondering. Yeah. Thank you very much for your interesting talk. And thank you very much for your ventures. Hopefully you venture into Brazil also. Okay?
Yeah, we are actually talking to Chile and other people. Latin America, we have covered. I think, yes, we will be traveling definitely. Only the corona has stopped us. I'll have visited Colombia at least twice. This corona, but could not go.
I have gone to Colombia several times for other purposes. Okay, thank you.
Yeah, one quick clarification, Professor. This when you have this algal bloom, there's a muddy greenish water. You bring clarity by treatment. What exactly happens? You are adding algae to clear the algae, wild algae there, or you are
actually
what exactly the transformation?
It's a very good question. In fact, it varies. Supposing it is the wastewater, the polluted water with a lot of algae. Basically, we divide algae into two groups, beneficial and harmful. So when the harmful algae grows, that is the pollution. When the beneficial algae grows, that is not a pollution. So what we do is, in Colombia, I think you have seen reservoir ponds that we are growing some selected species of algae, which are not growing in large number in those polluted water bodies because other cyanobacteria and the harmful algae are dominating. So what we do is we collect those species. Select only those very slow growing or not growing at all, the beneficial, so-called beneficial algae, bring them to our facility, give them a lot of nutrients, grow them in large number, put them back into the water body so that the number increases, the competition increases, these harmful bacteria, harmful algae are completely removed by the the increasing number of beneficial algae. That's what we do in treatment. So it is a natural system, what we are talking about. We don't add any chemicals or anything.
The clear water is represented by
yes,
beneficial algae water.
Yes, because we actually restore the ecosystem. There are harmful algae, it will kill the ecosystem. The fish will be killed, it will be colored and then covered, light may not penetrate. So what we make the system completely natural with all the food chain partners, including primary producers, secondary producers, the consumer, everything. But we don't add chemicals, but we increase the beneficial algae by bringing them to a growth facility, grow them in large number, and put them back in the water body so that they immediately float.
Yeah, one quick question, sir. This Phyco Plus, is it a nutrient of media supplement? Or is it for also used in the laboratory research?
No,
for the large scale?
It is actually added in a very, very small quantity, like you can say it is half kg per acre. Very small quantity, half kg per acre. And this is added
in the laboratory also.
No, laboratory, you need at least 1 acre minimum for this to work. So when we add this chemical, the nutrient, we add this on the surface. So we don't mix the pond or river or water, but we add on the surface, not the river, the ponds and lakes. We add on the surface. When it starts, dissolving, it takes action. So that's why the very slow quantity actually activates the bacterial and algal treatment system there in the polluted water body. Whatever we are normally going to achieve in 1 month, we can achieve within a week. So it enhances the natural degradation process by these nutrients, growth factors, and we also add some growth hormones. The formula
any other questions from the audience?
So I have a question.
Yes.
So I have a question. May I go ahead?
Yes, please. You are very clear. Don't worry.
Yes, sir. So it's about the continuous reactors that you have. What is the hydraulic retention time or the organic loading rates that you employ in those continuous reactors?
Actually, I showed a continuous reactor, but otherwise we'll be doing semi-continuous loading. So we normally maintain, I don't know how far you're going to say, we normally maintain 1:4 ratio. One ratio that we will be adding and 4 parts that will be remaining there in the tank always with the algae and all that. So 1 part we will be adding and removing every day. Sometimes if it is acidic, we go for 1:8 ratio. And it is addition and removal every day. It is semi-continuous process and that works.
So actually, I meant the hydraulic retention time or the batch processing time. Basically, the treatment time is what I was.
Treatment time is within 24 hours. Sometimes we take every hour also. Sometimes we take every hour. It depends.
So the percentage reduction that you mentioned in COD, BOD in some of the reactors.
Yes.
So this is achieved in 24 hours of treatment, is it?
Yes. That is why maximum 24 hours. You cannot go beyond 24 hours. But if the percentage reduction is very high, we can remove even within a few hours also. We don't need to keep it 24 hours. So we have done it based on the results we get, efficiency. We don't go beyond 24 hours. That is not allowed. That is the only limitation.
Okay. Thank you very much.
Yes. I think you have passed some technical, definitely.
Yeah, so that was our colleague, Dr. Tasneem Abbasi from the Pollution Control Department, sir.
Oh, okay, that's why. I never expected this.
So, thank you, ma'am, for your interaction and getting beneficial information.
Thank you, sir, for the opportunity.
I think if any more question is there, please come in inbox. We can collect and pass on to the resource persons. And because of small disruption, we are running short of time. Now we can move on to the next session. I'll request the.
So this is the latest review I've written in not latest October 2015. Phycoremediation bioeconomy. I think.
Very nice, sir. Very nice. Oh.
So thank you, sir.
Yeah, thank you for your very informative and exhaustive talk, sir. Let's all join hand in giving him a big hand of thanks. Applaud.
Thank you.